This problem is going to be a little more lengthy. You can pause the video and read over it so you know exactly what it's asking. But we're not simply going to calculate the population after a given time and a given rate. We're going to have to do a little more digging here. And if you look into the text, you see it gives us a couple things. It says, hey, we got a certain population in the year 2012, right? We have 2.865 million. And then in the year 2020, we have more people. We have 3.273 million. And the first thing it wants to know is, what is that growth rate? So to do that, we're going to use our PERT equation, P-E-R-T, and we're going to fill in some of the things we're given here. One of them is the final population in 2020. That is 3.273. Another thing we're given is P initial. That is 2.865. Okay, you have E. Okay, that's just E on your calculator. Let me get some little more room here. And then we have R. That's what we want. So that's my variable. I don't know what that is, but I do know the number of years between 2020 and 2012, right? Just 2020 minus 2012. That's the number of years there. You could put 8 in. That's fine. So what you're going to have to do is first divide each side by 2.865. Okay, and then, here, let me do this out down here. We got 3.273 divided by 2.865, and look what that equals. That equals E to the 8R. Remember, 2020 minus 2012 is 8. To solve this, it's an exponential equation. You have to do the ln of both sides, the natural logarithm of both sides. So I'm going to show that here. Take the ln of all that and the ln of all this. And what do you get? On the right side, things cancel out nicely, and you just get 8R. Okay, on the left side, well, that's what calculators are for. And then at the end of this, we're going to cancel out that 8, divide each side by 8. So once you can perform this calculation on the left, 1/8 ln of that fraction, that's going to give you what R is. And on my calculator, it says, crazy big decimal, but that's going to be 1.66%. Actually, the answer is something like, 0.0166 equals R, but I converted that to a percentage. Okay, so next step, at the current growth rate, what is the expected state population in the year 2035? Now that's a little more straightforward. All that's asking us to do is plug in. So we say P, and what is the year 2035? Well, that's interesting. I'm going to compare 2035, is that it? Yeah, 2035 to the year 2020, okay? Because I know the population in 2020. So that's going to be 15 years. Now that's an important number. That 15 year, that's our time span. And our initial population is the population in 2020, right? So what that's going to be is, let's see, what was 2020 again? Yeah, that was 3.273 million. I have my good old exponential function. My rate that I just calculated from above. Now, just to be brief, I'm going to write 1.66%, but I want you to write many more digits than this. Okay, use a lot, because every time you round in the middle of a problem, you're making an error there. So try to keep those errors small. And then we put the number of years in here, and my years is, I don't want to use parentheses there. My years is 15 years, right? The gap between 2035 and 2020. So plug all that stuff on the right side into the calculator. What you get out the other end is I'm going to round this again because I'm at the end of a calculation. You get 4.2, that's not what the calculation, 4.2 million. Okay, so that would be my answer right here. And of course, there's more decimals on there. I'm just rounding to be brief. Last part of the question is this. It says, assume a current growth rate, right? It's not always a great assumption, but we're going to just say, assume the current growth rate. In what year is the population expected to reach 5 million people? Well, this is a little different calculation. Now, I'm going to start with my PERT equation again. We have this guy, right? Well, the population will hit 5 million at some point. That's what we're saying. And I just want to know what year that is. So let's use 2020 as our comparison. 3.273 e to the, I already know r. I've been assuming that as my constant this whole time. 1.66 and use lots of decimals times t. So what we have to do here is another logarithm. So we're going to get 5 divided by 3.273, okay? And that's going to be equal to e to the, that was weird, e to the 0.0166t. Okay. Now you take the natural log of each side. You get ln of 5 over 3.273 equals 0.0166 t. And of course, every time I say 0.0166, you know you have more decimals than that. So we divide each side by 0.0166. That goes over here, and this is going to be your answer. Okay, if you punch that into your calculator, you get the following. You get that t is equal to, on my calculator, it's, let's see, give me a second here. This is going to be 25 and some decimals. 25 and some decimals. Now, here's the part where you have to just think this through a little bit. If it's 25 and a little change, in what year is that? Well, that's going to be the year 2020 plus 25. Okay, so my year equals 2020, that was my initial year, plus 25 and some change. Now, the change doesn't matter. I don't care if I'm in March or August. It's going to be during the year 2045. So that's how we go about this problem.